Hey guys, this is your review for our Unit 3, our intro into functions. So at the top you see all the different sections we went over in the book. Our review goes over all of these. So I'm going to go through this, make sure you're checking your work from yesterday to see if you got them right or not. If you have any questions, feel free to message me through the Remind app. You won't be bothering me. I'll be sitting on my couch all day. So just send me a message and I'll try to answer them as best as I can. All right, starting off with number 1. An oil rig in the Gulf of Mexico is leaking 100 gallons per hour. It started with 300,000 gallons. It wants us to find the input and the output. So remember, the input is what's happening, and the output is what the result is. Okay? I like to find the output first. So our output here is how many gallons we're going to have. Okay? So the output's going to be gallons. Okay? My input is what's happening. Well, it's leaking 100 gallons per hour. So my input is going to be time, and in this case, we're going to use the hours. Okay? Write a function in function notation to model this situation. All right? So the gallons after a certain amount of time is going to equal. Do y'all want to use H? Let's use H for hours. I think that'll be better. Let's do gallons after hours equals. Okay, so we started out with, okay, so right here, this started out with, whoops, I don't want to do that. No. This started out with tells you how to start out your equation. We started out with 300,000 gallons. So we're going to start my equation with 300,000 gallons. Now what's happening? It's leaking. So leaking means we're losing. So we're going to subtract 100 gallons every hour. Okay, so that is our function. Now it wants to know how many gallons are going to remain in the rig after 24 hours. Okay, so what does that mean? That means we are going to plug in 24 for our H. All right, so gallons after 24 hours equals 300,000 minus 100 times 24. All right, so 100 times 24 is 2,400. And then 300,000 minus 2,400 is going to be equal to 297,600 gallons. So that's how much is left after 24 hours. All right, moving on. Number 2. Miss Stalsack has started gardening. She buys a tomato plant from Lowe's with 13 tomatoes already on the plant. She continues gardening the tomato plants. As she continues gardening, the tomato plants grows 15 new tomatoes every week. Okay. Define the input and the output. All right. So let's see. The output is going to be the tomatoes, right? Yeah. She's getting out of this the tomatoes. And where do the tomatoes come from? They come from each week. So our input's going to be time again, but this time it's in weeks. Because each week she gets new tomatoes. All right, let's write a function. All right, so my tomatoes after weeks is equal to, all right, well, it says that when she first bought it, it had 13 tomatoes already on it. So we're going to start off with 13 tomatoes. The plant grows, so we're adding 15 new tomatoes each week. So it should be 13 plus 15W. It wants to know how many tomatoes will the plant grow after 10 weeks. So tomato after 10 weeks, so we're changing our W to 10 because we know weeks is 10 weeks, equals 13 plus 15 times 10. 15 times 10 is 150. 13 plus 150 is 163 tomatoes. I hope she likes tomatoes. I do not. But in 10 weeks, she's going to have 163 tomatoes. Alrighty. Here we go. Consider the function of the relations. It wants us to fix each to make it a function. Okay, so remember, a function, an input, or an x value can only have one output. Okay, so looking over here at A, anything in this first circle, in this first circle right here cannot be used more than once. But if you see, this -2 right here is being used twice. So we need to take one of those away. All right. So to fix it, because it tells me I have to fix it, what am I gonna do? Let's just take one of them away. If that did not exist, now it's going to be a function because each x value is only used once. All right. Let's look over here in part B. So again, anything in here cannot be used more than once. Is it happening? Yup. Looks like -5 is being used to 7 and 9. So what can we do to fix it? Well, just like the last one, I'm going to take one of those away. I'm going to take this one away. So -5 only goes to 7. It does not go to 9 now. Alright. Let's look at the third one. Anything in this first oval cannot repeat. Is it happening? Yeah, it's happening. Look at 7. 7 is going to all 3 different outputs. That cannot happen. So what are we going to do? We need to take them away. I'm going to take away this one, and I'm going to take away this one. So the only outputs that I should have is that 5 is going to 0, and 7 is going to 1, and that's it. Okay? So in part B, -5 only goes to 7. -4 only goes to 8. -3 can go to 8. That's fine, because the -3 only got used once. And then part A, we made it so -3 goes to 0. -2 goes to 0. That's okay. 0 goes to 1. 5 goes to 1. And then 9 goes to 2. As long as nothing in the first oval is being repeated, we are good to go. Alright, it wants us to do the same thing for D and E. So we're looking for any x values that repeat. So we have the coordinate 3, 5, 6, 5, 3, -2, 1, 3, -3, 4. Okay? Did any of those pieces repeat? You should all be saying yes right now because it happened right here. So how can we fix it? Well, let's change one of them. Let's change this 3. Let's change it to a 2. Because now we have 3, 6, 2, 1, -3, and now it's all going to work out. Alright, last one. Look at all my x values. 0, 1, 2, 3, 0. Okay, so which one repeated? The zeros did this time. So how can we fix it? We gotta change one of them to something else as long as it's not 1, 2, or 3. So I'm gonna change this guy. I'm gonna make this last point 4, 4. And now my x's are 0, 1, 2, 3, 4. And we're good to go. Alright, so remember, functions, x's cannot repeat. Oh, cannot repeat. I can spell. Alright. Here we go. State the domain and range. And let's decide if they are functions or not. Okay, so now we're looking at graphs. So remember, to be a function on a graph, means that it's going to pass our, our vertical line test. Excuse me. So I could draw a vertical line and it only touches the graph once. That's what's going to make it a function. So this first one, what is my domain? Remember, domain is all the x's that are on your graph. Range are all the y's that are on the graph, okay? And when I mean the graph, I mean the piece that's actually graphed here for you. So on this blue sideways parabola, what are all the x's that are available? Okay, so we're looking at my x-axis, which is this guy. Well, it looks like the lowest x-axis, the lowest x, is going to be down here at -3. And then my other side, see how we have arrows? That means it's going to go on forever. So all of my x's are bigger than or equal to -3. Because the parabola is just going to keep moving over to the right. Alright, my range. Okay, so we're looking at the lowest and highest y. But again, we have arrows this time. Okay, arrows means it's going to keep on going. Nothing is stopping it. There's no turning point. So since there's no stopping, we're going to have all real numbers for this one. Okay, that's a fancy R, or you can actually write it out. All real numbers. Either way. Alright, next. Is this a function? Yes or no? Alright, well, can I draw a vertical line anywhere and it cross it twice? Well, boom, right there. It hit it 1, 2 times, so that means this is not a function. Alright, part B. What is the domain? Alright, so we're looking at x's again. So we're looking at the ends here. They have arrows pointing both directions, which means my domain is going to be all real numbers. It also means that my range is going to be all real numbers. So when you have an arrow on both sides like that, no, I'm wrong. No, I'm not wrong. Because these are going to keep going up. Yeah, so range is even all real numbers. So when you have an arrow on both sides like this, okay, it's going to be all real numbers for both of them. Alright, because see how it's kind of curved up? It's going to keep going up. So my y's are going to get bigger. Alright, is this a function? Can I draw a line anywhere and it crosses more than once? Well, no, it looks like it works. So this one is a function. This is yes. Alright, remember what you can also do is you can take your pencil. I'm going to use this green line. We're going to pretend this is a pencil. Okay? You can take your pencil and drag it across the graph, and you'll see that it never touches my green line more than one time. Okay? Over here, look at this. The whole time it's touching it more than once, right? So that's why that one fails. But this one was okay. Alright? I'll save that for the other two. Alright, my next one, domain. So we're looking at the parabola. This time it's opening up. So we're looking at my x's. So we're looking here and here. I have arrows, right? So that means all real numbers. There's no turning point on the sides. So that one's good to go. Alright, my range, let's look. Okay, so there is no curve. These were kind of curving to show that it's going back up, right? These are just going to keep on going up forever. There's not going to be another turn. So my range, there is a turning point right here. And that is at what? -2? So all of my y's have to be bigger than or equal to -2. Excuse me. Alright, is this a function? Well, let's use my vertical line test. There's my vertical line. If I pass this through my parabola, notice it never touches it more than once. So this one is going to be a function. So this is a yes. Alright, last one. This is an oval shape. My domain. Alright, so there are no arrows, so there has to be a restriction of what x's and y's actually exist on the oval itself, okay? Not every x is on here. The only x's on this graph are between this x and this x. So what is that? That looks like what? -2 and +2? So your domain is in between -2 and +2, like that. Alright, how about the range? Well, same thing. This is as low as it goes, it turns. This is as high as it goes, and then it turns. So this is a y of 3. This is a y of -3. We always do the smallest one first. So -3. Your y's are literally in between -3 and +3. Alright, is it a function? I'll take my vertical line, go through it. Uh-oh, it's touching twice. Oh man, this whole thing. Yeah, so this is not going to be a function. It is touching my vertical line more than once at a time. So this guy is going to be a no. Alright, moving on. Alright, evaluate g of x, which is 2x squared plus 3x minus 5 with the given inputs. Okay, so what has happened is in each one of these, they've changed the x, okay, in g of x to either be a 2, -2, 5, or -3. So it wants us to actually plug it in. So it wants me to be 2 times something squared plus 3 times something else minus 5. So we are replacing what my x is. All right? For the first one, we're replacing it with the 2. So we're putting a 2 right here. All right, so 2 squared right here, that's 4. 2 times 4 is 8. Okay. 3 times 2, that gives me a 6. Then we still have minus 5. So 8 plus 6, that gives me 14. 14 minus 5, that gives me 9. So g of 2 is equal to 9. If I plug in 2, I'm going to get a 9 out of it. All right? Let's do it again, but this time we're going to use -2. Remember, guys, you can pause this or go back if I'm going too fast. All right? All right, we're going to plug in -2 this time. All right, so exponent first. So -2 squared is -2 times -2, which is +4. All right, 2 times 4 is 8. 3 times -2 is -6. Still have that minus 5 on the end. 8 minus 6 is 2. 2 minus 5 gives me a -3. So when I when I replace the x with a -2 in my function, I get -3 out of it. All right. Let's do another one. This time, what's my x to be a 5? Okay. 5 squared is 25. 3 times 5 is 15. 2 times 25 is 50. 50 plus 15 is 65. So this whole thing is going to equal 70. So when we plug in 5, we're going to get a value of 70 in this function. See how when we plug in a number, we get a number out of it? Okay, that's always going to happen when you replace the variable with a number like that. All right, last one. G of -3. -3 squared is 9. 2 times 9 is 18. 3 times -3 is -9. Still have a minus 5. That gives me 9 minus 5 and 4. So when we plug in -3, we get a 4 as an outcome. So all this time I was changing my x, I was changing my input. All right, and what we got out of it each time was our output. Alright, moving on. Complete the given operations on the following functions and simplify. Okay, so we have F, G, excuse me, H, and J. So, let's make this thin marker. J plus F. So make sure we write them in order. So J is negative 2x plus 7. Once we add to that F, which is 5x plus 2. Okay, so we're just going to combine like terms. Negative 2 plus 5 gives me a positive 3. 7 plus 2 gives me 9. That's all we do there. Alright, I'm going to go down one. Yeah, I'll go down one. H minus F. Yeah. Alright, so we have H minus F. Write it in the order it gave it to you. H is x squared minus 2x minus 4 minus F, which is 5x plus 2. Alright, remember when we subtract, we're going to have to distribute that minus sign. So we get x squared minus 2x minus 4. Now it's plus in the middle. We change all the signs now. This becomes minus 5x. This becomes minus 2. Alright, combine like terms. Nothing else has an x squared, so that's just going to stay here. Negative 2x minus 5x, that gives me a negative 7x. And then negative 4 minus 2 gives me a negative 6. So when we do h minus f, that's what we get. Alright, let's do the middle column. Alright, it wants me to do g minus h. Remember, make this one first and do this one second. So g is 4x squared plus 3x minus x squared minus 2x minus 4. Just like last time, we're going to change all of the signs on the second half. This does not move. Now it's plus negative x squared plus 2x and plus 4. Alright, combine like terms. X squared, x squared. So 4 minus 1 gives me a 3x squared. 3x plus 2x. 3 plus 2 gives me 5. And then I had just a plus 4 down here, so that stays on the end, like that. Alright, down here we have g plus j. So g plus j. 4x squared plus 3x plus negative 2x plus 7. We are not going to change signs or distribute because there is no minus sign. Okay, so we're just going to combine like terms. Right here, there's only a 4x squared, so that's still there. 3x minus 2x, they both have x's, so 3 minus 2 is a positive 1. And then we just have a 7 left over. Right there. Okay? Alright, these last two are multiplying. So remember we looked at making a table for these if you wanted to. This first one, f times j. So here's f, here's j. It is a 2 by 2, which just means it's two binomials. So you can write them next to each other. So 5x plus 2 like this, and then just do FOIL, okay, and distribute. So 5x gets multiplied to both of them. 5x times negative 2x gives you negative 10x squared. 5x times 7 gives you 35x. And then you do the same for 2. You do 2 times negative 2x and 2 times 7. 2 times negative 2 is negative 4x. 2 times 7 is 14. Combine these guys in the middle because they're like terms. So we have negative 10x squared. That gives me 31x and then plus 14 to be our final product for that multiplication. Okay. Last one, g times h. So there's g, it's a binomial. All right, h is a trinomial. This is when I'm going to use the table. Okay. So I'm going to put 4x squared and 3x on the side. I'll move that down a little bit so I have room. 4x squared, positive 3x, all right? And then across the top, I'm going to have my h. X squared minus 2x and minus 4, like that. All right, let's multiply. So 4x squared times x squared. Well, there's a 1 right here. 4 times 1 is just 4. Excuse me. X squared times x squared, we get to add the exponents. 4 times negative 2 is negative 8. There is an exponent of 1 right here, so that becomes x to the power of 3. 4 times negative 4 is negative 16. And the x squared just stays because there wasn't another x squared to put with. Alright, bottom row. 3 times 1 is just 3. X times x squared gives me x cubed. 3 times negative 2 is negative 6. X times x gives me x squared. 3 times negative 4 is negative 12, and then just an x. Alright, after we do this, we are looking for common terms. So I see those pieces with have an x cubed, and, excuse me, I see these pieces with have an x squared. So when I go write my final answer, highest exponent first, which is 4x to the 4th. Alright, combine like terms. This gives me minus 5x cubed. And then negative 6 minus 16 gives me negative 22x squared. And then finish it with negative 12x. And that's my answer for that one. Alright, now we're going to get into interpreting our graphs and their features. So here we have a graph that represents a rock climber's height as she ascends a hill. Alright, so the word ascends right here, that means climbing up, okay, which is why our graph is increasing. Alright, the graph is, okay, is it linear or nonlinear? Meaning, is it a line or not a line? Well, I don't see any curves or turning points. This is definitely a linear graph. It is a straight line. Alright, is it a function? Alright, well, let me draw myself a vertical line again. Let's use this to test. If I take this and drag it, look at that. It only touches it at one spot. Never touches it more than once. So, it is a function. So we can say yes. It passes a vertical line test. I'm going to call it VLT for short. Passes the vertical line test. Alright. What is the y-intercept and what does it represent? Okay, so y-intercept means it's crossing our y-axis. So about right here, what number is that? 10. So the y-intercept is at 0, 10. That looks like a 6. It's definitely a 10. What does that represent? Okay, well, it looks like my x values are seconds and my y values are feet. So it looks like at 0 seconds, she's 10 feet off the ground. So this is showing, it's showing her elevation when she started. I can't spell. Elevation, right? Is that how we spell it? No, it's not. Oh my goodness, guys. It's the medicine. Alright, her elevation when, when she started climbing was 10 feet. So she was already 10 feet above the ground when she started climbing. Alright. Why would there not be an x-intercept for this situation? Okay, so an x-intercept here would represent where she is starting on the ground, and she's not ever on the ground. It looks like she's already starting above the ground. Maybe she's already on a rock or something. She's going up a hill, so she is never on the ground. And she's always climbing up. She is always increasing her height. So she's not going to go back down to the x-axis anywhere because she is continually going up as time goes by. So as far as she goes, as time goes on, she is increasing the whole time. All right, next one. Here we go. These were all the other key features. So let's look at this one. It's multiple choice, which yes, there's ones like this on your test on Wednesday that are also multiple choice. So you got to pay attention though. All right, I'm going to show you some tricks to help. Consider the following graph of an absolute function. Here it is. So we're looking at this guy right here. Okay. And wants to define the domain. Well, here we go. Trick number 1. We know domains are talking about x's. So I can go ahead and cross off A and D because they're not talking about x's. All right. B says that all the x's are less than 3. And C says all the x's are all of them. All right. Well, let's look at B. Let's look at where is positive 3. It's not even on here because this is my x. This is my y. It's not even showing me x of 3. Okay? Look at the sides of these arrows. Okay? They're showing an arrow showing that it's never going to stop. It will always go to the left. Over here, it'll always go to the right. So my domain is going to be all real numbers. All right, my next one wants me to define the range. Well, my range are my y's this time. So that guy's out. So my options are y's are bigger than 3. They're all the y's, or y's are less than 3. Okay? Look at this peak right here. This is where my graph is stopping. There is a turning point. Okay? So the y's have to stop and go somewhere else. That means all real numbers are out. Alright? So where is it stopping? It's stopping at y is 3, which we could have guessed because that's what my options have left. Now, are all the y's bigger than 3 or less than 3? Well, look at where my graph is. It's all below 3. So all of my y's are less than 3. All right, where is my graph increasing? So if I were walking along, okay, let's say here, look, here's Miss Similar. Woohoo, here I am, okay? Let's say I'm walking across this graph. Okay? I am first going to be increasing, right? Going up the hill. So where is this happening? Well, my options, let's see here. Where x's are bigger than 0, x's are less than 0, less than -2, bigger than -2. Well, I stopped increasing right here, which is where x is -2. So my zeros are out. Right? When I was walking, all of these x's, look at that, -4, -3, okay? Those are all x values that are less than okay, less than negative 2 as I walk up this hill. So I am less than negative 2. Alright, so where is my graph decreasing? Well, again, A and B are out because my turning point is at negative 2. Okay? We just saw me climb up, now I'm going to fall down. That's everything that's bigger than negative 2. Because look, now here I'm at x of negative 1. And then down here, x of 0. I'm going to keep going, x of 1. These are all x's that are bigger than negative 2. So D is our answer here. Alright, last one for this one. Identify any relative maxes or mins. Alright, so let's talk about your turning point, which is this guy right here. Okay? Is this a peak or a dip? Peak or a dip, okay? It is a peak, which means we have a maximum. So cross out the minimums, not a possibility. Alright? What is that coordinate point? Remember, coordinate points go x's and then y's. The x value here is negative 2, and the y value is 3. So our answer is going to be A. All right? 2 more of these. All right, consider the following graph of a quadratic equation. All right, let's do our domain first. Remember, that is our x's. Okay? So we know that the y's have to go away. Can't be my answer. Look at the ends over here. Arrows. There's not turning on the sides. Okay, so because of those arrows, all real numbers. Alright? Alright, our range. That's my y's, so B is gone. Where are all the y's? Well, there is a turn. There's a direction change. So it can't be all real numbers. Where is the turn happening? It's happening at negative 3. Okay? And it looks like all of my y's are bigger than negative 3. So my answer is A. Alright, increase and decrease. Let's use Miss Similar again. Hey guys! Look at me with the flu. Woohoo! Alright. So here we go. Miss Similar is walking this graph. She's going to start up here. When I move left to right, what's going to happen? Am I going to climb up or fall down? I am going to fall down. Okay? As I fall down, I reach a point, right, where I'm not falling down anymore. Where is that point? That point is where x is negative 4. So that means these guys are gone. Okay? I fell down on the left side. So I'm decreasing. Look at that. So we're down here. We're actually about to answer this question. I was decreasing first. So where my x's are less than negative 4, I fell down. But as my x's get bigger, as they are greater than negative 4, that is when I'm going to start climbing up the parabola again. All right, is there a max or a min? Yes, there is. That's our turning point. All right, it is a dip this time, which means we have a minimum, so maxes are gone. Remember, we write our coordinates as x, y. The x is negative 4. The y is negative 3. So our answer this time is D. All right, last one. We can do it. All right, this one's special, okay? It's different than the other ones. It's called an exponential function. We are still going to look at the same features of it, okay? Our domain, again, we're looking left to right. As we see, there are arrows. So once again, all real numbers. And once again, we know domain is x. So get rid of our y options, okay? Range, we know is the y's. So get rid of my x options. All right, so let's look at this. It is slowly approaching this line, and it's never going to cross it. Where is that? Looks like it's at -2. So all of the y's are bigger than -2. All right, where are we increasing and where are we decreasing? Okay. So here we go, Miss Similar again. So as I climb or I go across this graph, what's going to happen? I am going to fall down the entire time. I'm never going to climb back up, am I? If I walk across left to right, we will always be decreasing. Always, always. So what does that mean? That means increasing does not exist. It's not going to happen. It's nowhere. And the entire thing is decreasing. Because there's not a turn point, there isn't an increase and a decrease. That means that there is no max or mins. There was no peak and there's no dip. That's when we go from up to down or down to up, and that's not happening in this graph. All right, guys, good luck. Hopefully I'm back. If not, I'll see you when I get back. Again, if you have any questions, please message me on Remind, and I will do my best to answer whatever you guys need. All right? Miss you. Bye.